Let's start with a square. Then we will pull two diagonals of our square. Then we will mark the center of the upper side of the square, and from this center we will pull two lines to the bottom left and the bottom right corner of the square. In this way we will form this really nice deltoid, or a kite if you will, with the area of one squared unit. The question is, can we somehow calculate the area of our red square? So if you want to try this problem for your own, you can pause this video right now and then come back and check the solution. Alright, so let's solve this one. So I'm going to start this problem with a quick reminder about deltoid, or a kite. A deltoid, or a kite, is a quadrilateral with reflection symmetry across a big diagonal, and it has two distinct pairs of adjacent sides that are equal. So let's pull the big diagonal of the deltoid and let's label it as D1, and let's pull the small diagonal and let's label it as D2. In this way, the area of the deltoid will be equal to the half of the product of its diagonals. Now, we know that the area of our deltoid from the sketch is equal to 1, so we can simplify this to get that the product of the diagonals of our deltoid is equal to 2. Next, we also know that the deltoid, or a kite, has two diagonals that are actually perpendicular to each other. So we're also going to use this fact in our favor here. Alright, so let's go back, and first let's pay attention to the bottom left corner of the square and to this orange acute angle. Also, let's notice the acute angle at the top left of our deltoid. Those two angles are actually equal. We know this by the theorem of the angles in parallel lines. This theorem states that if we have two parallel lines and we pull a line through those lines, which is actually called a transversal, then each pair of corresponding angles on the same side of the intersecting transversal are equal to each other. So if you take a look at the sketch on the left, you can see that we have two vertical lines, so those lines are parallel, and we have this red transversal line. With this in mind, we can conclude that those two acute angles must be identical. Alright, so now let's go ahead and label the sides of the square as S. And we can say that the upper left segment of the upper side of the square must be equal to the half of the side of the square. Next, we will take a look at this green triangle and this blue triangle. Both of those triangles are right-angled triangles, and both of them have the same acute angle. This means that those two triangles are actually similar. So let's label the legs of the smaller triangle as A and B, and let's isolate the big triangle and the small triangle as well. Now we can use the rule of similarity. We can say that the relation between their legs is equal, so B over A must be equal to S over S over 2. Now we can simplify this to get that B over A must be equal to 2, which means that B must be equal to 2A. And let's substitute the values of B for 2A. Alright, so now let's have a look at the small triangle at the bottom left of our kite. And this is also the right-angle triangle which we will isolate here. Now, notice that the hypotenuse of this triangle lies on the diagonal of the square, which means that it must be 45 degrees from the vertical line. With this in mind, we can conclude that this triangle is actually an isosceles right triangle, which represents the half of the square. So this means that the length of the other leg of this triangle must be A as well. And now let's settle this triangle on the right side of our sketch. And you can see that we have the half of our kite. And let's use the fact that the big diagonal of the kite is a symmetry line, so we can draw the other half of the kite. Now let's notice that the big diagonal of this kite has the value of 3a, and the small diagonal will have the value of 2a. Now we can use those values and implement them in our previous formula, and from this we will get that 3a times 2a must be equal to 2. Now we can simplify 2 onto both sides of the equation, and we will get that 3a squared is equal to 1, which means that a squared must be equal to 1 over 3. Now, let's go back and put our kite back into our square. And we will notice another fact. We know that the diagonals of the square are intersecting at the middle point of the square. So this means that the big diagonal of our kite must be equal to the half of the side of the square. So this means that 3a must be equal to s over 2. Now we can simplify this to get that a must be equal to 1/6 of the side of the square. Now we will substitute this value into our first equation, and we will get the following. Now we will of course calculate the square of the left side, and then we can simplify by multiplying both sides with 36 and get that s squared is equal to 12. Now remember, we are looking for the area of our big square, which is equal to s squared. So now we can just substitute the value of s squared, and we will finally get that our wanted red area of the square is equal to 12 squared units, and this is our solution. Well, I hope you guys enjoyed this interesting problem. If you did, do not hesitate to leave a like or subscribe to the channel for more content like this in the future. And of course, if you found another way to solve this problem, please write it down in the comment section below. And again, as always, until next time, see you all and take care.